All right, class. So what we're going to do today is we're going to add on to what we basically started yesterday. We're talking about characteristics of functions. Okay. So what we're going to do is we're going to deal with two type of functions. The only two functions we're going to deal with this year. The first one is going to be a linear function, and the second one is going to be an exponential function. All right. So we have the domain, range, x and y intercepts that we talked about yesterday, increasing or decreasing, maximum or minimum for this first equation. So for this first graph, we're going to talk about this graph. First of all, this graph is a linear function. Okay, so we have a linear function. And again, why is it linear? It's linear because it's a straight line. The key word in that is linear. The key word in linear is a line. So if you see a line, that means it's a linear function. All right, so let's go ahead and move a little bit to the domain and range. Domain is talking about what values, guys. Your domain is talking about your x value. So I put x here. All right. So we're talking about my x values. So let's look at the x values. Let's look at this graph. This graph is starting from the bottom, from left to right, and it's moving up. Now, we know at the end of this line is going to be arrows. So the arrows means you're moving to what? X-axis. So we go to our x-axis right here. Okay? And that's what we're trying to read. We're trying to read our x values. So looking at this, I know at the end of this line, because it's going to continue to move on, it's going to be negative what? Negative infinity. Remember the car we talked about that last year? We're talking about infinity. Negative infinity keeps going, 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 and never stops. And if you go to the right side of your line, that's positive infinity. Okay? It's going to be very important when you're trying to deal with lines that never stop. So, since we're dealing with set notation, so this first one we're going to deal with set notation, meaning we're going to deal with inequalities, okay? We don't have an inequality for negative infinity to positive infinity, so we're going to write all real numbers. That means it includes all the numbers except imaginary numbers, and we're not going to get into that right now, okay? But it's all real numbers. That means you're dealing with the negatives, positives. You're also dealing with the fractions that's in between these lines, so you're including all those values. Okay? All right, so our domain for this one is all real numbers. Let's move to our range. Now your range is talking about what, guys? Your range is talking about your y values. Okay? So I'm going to make that green. So it's going to be my y values here. So I'm going to put y right up here. Okay? So we're talking about my y values. My range, let's look at this again. Again, I have arrows. My graph isn't stopping anywhere. Okay? My graph isn't stopping anywhere, so that means my graph is going to continue to move on until negative infinity, which is right here, to positive infinity. Now, we can't put that, you can't put negative infinity to positive infinity as far as that in set notation, so we're just going to write, again, all real numbers. That's including, I'm just going to put it like this. That's including your negative numbers, your positive numbers, fractions, everything is included in this graph. So now let's move on to what we talked about yesterday. X-intercepts and y-intercepts. X-intercept is where your graph is crossing the x-axis, which would be at this point right here. Okay? Where it's crossing the x-axis. And your y-intercept is where it's crossing the y-axis. So let's try to do the x-intercept first. Okay? Looking at this, my graph kind of intercepts right about here. It's not necessarily on the 1, but it's in between 1 and 2. If you look at it very closely, your line intercepts the x-axis between 1 and 2. Now, I mean, do you know that all the time? No, you don't. So for what we're going to do right now is we'll just do 1.5, okay? So how do I write that? You know you're dealing with the x-intercept, and we talked about this yesterday, x, comma, 0. So it should be x, whatever the number is, comma, 0. For today, we're going to say the x-intercept is parentheses 1.5, comma, 0, okay? That should be a 1.5, not a 1.15. All right, there we go. I'm writing with my hand, so that's kind of messed up. All right, so 1.5, comma, 0. Okay, good job. Now let's look at the y-intercept. The y-intercept is a little bit better because you see it actually hits a point like it's intersecting about, what's that, negative 4? So to write my y-intercept, we know that's always going to be 0, comma, y. Okay? So now we're going to write 0, comma, Where's the intersecting at? -4. Boom. That's our answer. Good job. All right. Now let's look at this. Let's move to increasing or decreasing. Pretty easy. You go from your notes from yesterday, increasing when it goes from, you read it from left to right, so it's going up. If it's going up, it's increasing. If it's going down, it's decreasing. Very easy, guys. This is what? Increasing. I'm not even going to write that. I'm just going to circle increasing. Boom. There we go. Now, so this might be a little, I'm not going to say difficult, but it might give you a little, some problems right here. All right? Do we have a greatest value? Meaning, does your line stop at a point? If it's talking about how we explained it, where you have arrows, it's always going up, never stopping. Do you have a maximum? No. Let's look at this one. You also have arrows going down, never stopping. Do you have a minimum? No. So you guys, you see, it is possible that you can have a maximum and you don't have to have a maximum minimum all the time. Okay? So you do see that right here. All right? Go ahead and pause, guys, and get your notes down. Please ask me any questions. If you have any questions at all, go ahead and tap me. I'll be walking around the classroom, so please ask. All right, so now let's move to the second equation. Okay? Now, looking very different from the first one. Is this a linear equation? Do you see a straight line? Notice, this isn't a linear equation, guys. And let's see if the people who can remember from last semester, what type of equation is this one? You guys are correct. It's an exponential function, okay? It's not the right function, but exponential. We know this because we see a curve. It's a curved line, okay? And we also have arrows at the end of this. Let me go ahead and write that. All right? So, same thing. It has a domain range. We go through the x, y intercept. If it's increasing, decreasing, if it has a maximum or a minimum. And we got something new, horizontal asymptote. Okay, we're going to get to that when we go back to, you have to go back to your notes on that one. All right? But let's use set notation for this one. I'm sorry, not set. We're going to use interval notation. Interval notation, we're not using inequality signs. Okay? We're actually going to be using brackets, going to be using parentheses, and using the infinity sign now. Okay, so let's go ahead and knock this out of the way. So domain. Domain talking about, again, your x values. We have those arrows at the end. Okay? This end of the graph is going continually on past the graph, right? It's going to continue going on and on and on. The same thing with this one. This end of the graph is going to continue going further, further, and further, and continue expanding out to negative infinity. This was going to, the x values over here continue expanding out to positive infinity. So the question is, if we're using interval notation, how do we write this? Are we including this number? No. So we're going to write parentheses, negative infinity, comma, positive infinity. Just that easy. You're not including those numbers. It's not a closed number. It's not a closed circle or anything like that. So you don't have to put the bracket. Okay, we'll get more in depth to that a little bit later. All right, so let's move to our range. Range, again, is talking about your y values. Okay, so let's look at our y values. Uh-oh, something's a little different. Something's a little different right here, guys. It's not like the last problem we did. If I'm looking at this, does my graph go to negative infinity for the y values? That's this line right here. These are my y values. Looking at only this line right here. Okay? This line right here. So, is it going to negative infinity? If I'm looking at this, no, it's not. But it is going to positive infinity. So we got to figure out where's my graph starting at. That's where the line, this little asymptote, comes into play. Now take a second and go back to your notes and read what an asymptote is. All right, so if you went back and read the what asymptote is, guys, the line that the graph comes to but never crosses. Okay, it never crosses. So let's look at this graph, and I'm going to erase everything up here right now. So hold tight. Looking at your graph, this exponential function, is there a line that it comes to? It looked like it's touching, guys, but its actuality is never going to touch this line. And if I could draw this right, it should be this line right there. It looks like it's touching, guys, but trust me, it's never going to touch that line. Okay? So this, in this case right here, this is called your asymptote, but that's going to help you find your range. Okay? All right, so let's go back to the range. We still haven't got off of that yet. So where's this line starting at? So all my points would be above this number. I see 2, I see 4. What's that number in between? 3. So your range, all your y values will start at 3 and move up to what? If this is an arrow right here, that means it's moving to what number? Infinity. So now, boom, parentheses. We're not including the number 3 because the line would never touch 3. So that's why it's going to be a parentheses and not a bracket. Okay? You're gonna get better at this, guys, as we keep moving on. But let's go ahead and keep moving. All right. So now we have my x-intercept. X-intercept. Does this graph cross the x-axis? Where's my x-axis? Let's check and see. My x-axis is right here. Oh, let me go back. All right, again, it's not that good, but we'll work with it. Okay, but you guys see where I'm going at, right here. All right. So, is the graph coming there? Is it touching the line? No. So, there is no x-intercept. See how easy that is? Not hard at all. I know you guys are like, I don't know what I'm doing. This is so easy. Y-intercept. Is my line crossing the y-axis? Yes, it is. And it's crossing at what point? I just put an arrow to it. 4. So how do we write the y-intercept? Remember, the y-intercept is always 0, y. So it should be 0, what's my y-coordinate? 4. Easy. There we go. See? Just that easy, guys. Just that easy. Let's move to the next one. Let's keep moving. We found at the end. Let's finish this line. Let's finish this thing, baby. Let's go. All right? So, we have increasing or decreasing. Read from left to right. Is it going down? Is your finger going down or up? It's going down, so my graph is decreasing. Good job. Good job. Let's keep it up. All right? Let's look for a max or a minimum. Now, again, is my line stopping? Do I have a maximum point? No, because my line is continuing. Moving on. It's never going to stop. So I don't have a maximum. Do I have a minimum? I could have a minimum in this case. It could or could not be, but we'll say we do have a minimum. Okay? Our minimum point will be what? What do you guys think? If anything, it could be 3. We could say 3. All right? We could say 3. So in this case right here, we'll say our minimum point is coming around 3. Okay? But in actuality, you probably won't have a minimum. But we'll just say, just for the sake of saying it, we'll say it has a minimum for the day. But let's go to the next one, the most important one, horizontal asymptote. Now, we already drew the line. Which lines did it approach it but never coming to an end? You're right, guys. It's actually in your range. It's going to be 3. To make it real simple, guys, whatever the first part of your range is, it's always going to be your horizontal asymptote when you're dealing with an exponential function. Okay? So if your range starts at 3 to infinity, just know your horizontal asymptote is going to be y equal 3 because it's talking about those y values. Okay? All right, guys. If you have any questions, please ask. Let's get started on our work for today. And again, great job. If you have any questions, again, ask me, guys. All right? Let's get to work.